This is from the TKI website, and we're looking at artichokes. So I'm going to call artichokes X and tomatoes Y. Be careful in this one that you always use artichokes as X and tomatoes as Y, because sometimes they change the things around. Right, we need to use linear programming. We want to maximize the income. It repeats us around here, tomatoes and artichokes, and we use the constraints, and we have to communicate our findings. So let's look at the next part. Here's our resource sheet. We've taken artichokes as X, tomatoes as Y. We want a labour equation, and we've got up to 1,002 hours of labour. We have a hectare equation. Write that, or we see it's already written there, but I'm going to use X and Y. And we also have that he needs at least 30 hectares of tomatoes. Write that as one equation, remembering to use Y, and he needs at least 10 hectares of artichokes. We're going to graph those four constraints. This is how the great tomato fight gets started in Spain. Check out the helmet. For the labour equation, go to 120 and 60 using your 2-intercept method. We're using shading out. Now do your hectares equation, keeping the area below because Y is less than, so we shade out above. We want to keep that X is greater than 10, so we shade out below the line. And then mark in your 4 points. To work out point C, put them in your calculator, simultaneous equations in two variables, using this equation and this equation, because it's where the red and black meet. And you can do the same for D if you can't work it out. Or read them off your graph if your graph is accurate. And mine's not too bad. We now need an income equation, so go back to the question. And we are having fun too, remembering that your artichokes are X and your tomatoes are Y. Test those points in your income equation. Test each of these points in the income equation using A, B, C and D respectively, and work out your income for the maximum. So point D would give us maximum income of $1.8 million, producing 60 hectares of artichokes and 30 hectares of tomatoes. Now for the future, it is unknown what he will get, but he's got a ratio of 1 to 2. So if his income was 10,000 for the artichokes, that's tomatoes to artichokes, then it would be only 5,000 for the tomatoes. Because I started off this equation with artichokes first, my ratio will be 2 to 1, because we've got our artichokes to tomatoes, we've got our X and our Y. So you could use just 10,000 and 5,000, you could choose any numbers as long as you get the correct ratio. We're looking for the equation of that line. The gradient is the important part. So by isolating Y and putting the 10,000 X to the other side, then dividing by 5,000, we get this equation. We get that Y equals that. It can be simplified down to, and we're only looking at the gradient part, so we want a gradient of -2, and we're going to see how that applies with our graph. I think it's also a spectator sport. So here's our graph, and we want the income to have a gradient of -2. So move that dotted line up all the time at -2. So keep shifting the -2 gradient up, and we can see that the line, the black line, which is the labour equation, also has a gradient of -2. So anywhere between C and D will give us multiple solutions, and that's how you work out the excellent part. And write out your findings, and that's your report. I hope that was helpful today. See you next time.